Okay, so today we are talking about functions and objects. So functions, we've talked about how JavaScript is like the brain of uh, the setup in a web application. When you have your HTML as your kind of skeleton, you have your CSS as kind of your muscles, your muscles flesh, the things that flesh out and make the application look like something, and then JavaScript being the brain. Really, the functions are at the core of the brain. They are what enable JavaScript to do stuff. A good example of a function, just on a high level, is that console.log, right? When you say console.log, you print something to the screen. That's like an action. It's like a verb, right? Versus a variable, which holds information, or data type, which are types of or describe the data, describe the information. A function performs commands, performs actions. Functions are reusable. They're reusable chunks of code. You can use them again and again. And they are kind of split up into two concepts. There's the function definition and the function invocation, function call. The definition is what's shown here on the right, function bake cookies. We're defining this function, bake cookies, and inside of it, inside of these curly braces, we're saying all the stuff that bake cookies will do when you call it, when you tell it, okay, bake cookies, it's time to go now. Conversely, you have the invocation. You have the actual function call, right? That is us finding a place in code to use double parentheses to say, okay, function, all this stuff that I told you to do before, go, do it now. And you can do that multiple times. You can invoke a function as many times as you want in your code. And so that's why when we say it's a reusable chunk, it's something that you can define and then use again and again. A function is similar to a recipe, right? In that definition, you have a list of commands, a list of instructions to do. And when your function is invoked, when your function is called, it executes those instructions one by one in order. So in our bake cookies function, in our bake cookies recipe, we have the first thing that happens is we choose a flavor. We have this var flavoring is equal to flavor, and flavor is brought in as a parameter. We'll talk a little bit about that in a minute. But you have this flavor value that is passed in. The first thing we do is choose a flavor. We set the value of this var flavoring, and it can be anything, right? Because we can reuse this, it can be different things each time. It can be peanut butter, it can be chocolate, it can be caramel. And so the next thing that happens is we create our batter. We add flavoring plus the number of servings, and we get a value calculated from that, and we store that into batter. Then after that, we call this other function, preheat oven, and then another function after that, add cookies to cookie sheet. So both of those functions defined elsewhere are being used here to do different things. And so it executes these one by one in order, and it will execute it anytime you write the function name with those open and closed parentheses beside each other, like you see on preheat oven, add cookies to sheet. So here are some examples of what we're talking about when we're talking about parameters, right? We're used to defining variables in the way that we do on that first line in baked cookies, right? Var flavoring is equal to something, assigning something a value. There's another way that you can assign or pass in a value for a variable when you're defining functions, and that is with parameters. In baked cookies, function baked cookies, flavor and serving are both parameters. They're like value. They're like variables that get their values from values that are passed in when you call the function. So if you look at that baked cookies down at the bottom, those two examples, you have baked cookies and you pass in chocolate, flavor will now equal chocolate, and servings will now equal 5. You can also call the function again and pass in completely different, what are called arguments, the actual values that you pass in to take the place of those parameters, those variables are called arguments. So we have variables, we have parameters, and we have arguments. Those will be defined once again in the workshops, but you can pass in different values and you can run the same function multiple times and have different outcomes based on the arguments you pass into it. So in the second example, instead of our batter being 5 servings of chocolate, it's 10 servings of vanilla, which would make an entirely different cake, right? So those are parameters and arguments. Here's an example. Add 4 numbers. We have this function. We have the definition up at the top here in green, and then we have the invocation, the function call in black at the bottom. So the first thing that happens, right, is we have parameters, num1, num2, num3, num4. In the definition, those are all defined between those 2 parentheses after add 4 numbers. And then if you look down at the bottom where the function is actually called, you can see that the arguments for those parameters are the numbers 1, 2, 3, and 4. So we call this function, and what does the function do? On line, the first line of the function, you add num1, num2, num3, and num4 together. And whatever the result of that is, whatever the sum is, you store that in variable sum, in var sum. So now var sum holds whatever the sum of those numbers is, and we return sum. This return keyword is something that you can put in a function that will immediately stop the function. So if I had written console.log, the function is done below that return sum, that would not print to the screen. That would never execute. As soon as the computer, the execution, sees return in a function, it is going to immediately stop execution. What return also does is whatever value or whatever thing you put to the right of it, it yields that. It makes the output of the function that thing. So in this case, the output of the function is this sum variable, whatever the value of sum is. Returning, I like to think of it like in our cake example, bake a cake, right? Like I put all of these things into a batter, and I put all these things into an oven and in a cookie sheet, and then I turn on the oven, I let it bake for 25 minutes, and then when I open up the oven and take something out, the output is a cake. So now I have this thing, right? And I could store that in a new variable. I could store it in like a var cake. In this case, what happens here is you have add 4 numbers. It adds those numbers together. And it's almost like we can erase that add 4 numbers, 1, 2, 3, 4, and write, I believe it's 10, right? Whatever the sum is, whatever the value that return keyword returns, whatever it yields, is going to kind of take the place of the function there. And that value will then be stored in my sum. So in this case, just to go over it one more time, we have 1, 2, 3, and 4 passed in as arguments. So now num1 is 1, num2 is 2, num3 is 3, num4 is 4. Then we define a variable sum. We declare sum, a variable declaration, and that is going to be equal to the sum of 1, 2, 3, and 4, which is 10. So now var sum equals 10. And then we return sum. So we return 10. What happens is add 4 numbers, outputs, yields the number 10, and then that number is stored in my sum because we have a variable declaration attached to this, this function call. So now my sum is equal to 10. Sorry about that. Any questions on functions and on the return keyword before we move on?
Is the return just making it kind of simpler? Is that the reason for it, or?
It's a way to get a value out of a function, right? Like it's a way to access that 10 from where the black font is, from where my sum is, right? Technically, the code inside of add 4 numbers is separate. It's kind of separate from the rest of the code. So in this way, it allows us to have a specific output, a specific result. When you say make it simpler, what do you mean? What are you thinking?
It looks like in math when you kind of just like you're like isolating the actual like numbers from like that num1, it becomes like a 1, and it's like you just, and then you put the added 4 numbers like outside of it. So it's like you would multiply the added 4 numbers into 1, 2, 3, 4, and you'd come out with like the original var sum. That's what it like kind of looks like to me. But
yeah, I think it's kind of similar. The way that I like to think about it is just like the function spits something out. You know, it's kind of like I hire someone to do something. Like I hire someone to write me a paper, and I really don't care what they do in the 3 hours that they have to write the paper. All I care about is that they come back and they hand me something, and that thing is the paper. Now I have a value. So the return is kind of like this worker or this person outstretching their hand and giving you something so that you can take it and run with it.
Gotcha.
That makes sense?
Yeah.
Okay. Cool. Yeah. Any other questions? Okay. Moving on into objects. Objects are really cool. Objects are data structures, which means they're a way of storing data. Like, let's say I want to store some form of data in like a collection, and I don't want it to just be a number, right? I want it to be multiple numbers, or I want it to be multiple strings, and I want them all bundled together, all part of the same thing. An object is unordered, and it is set up by key value pair. That means that for every value that's stored in the object, you have a key, a string that is that enables us to look up the value. It's kind of like a dictionary. Um, these objects store these values in these things called keys. They're strings, they're unique strings, and they are associated with a value. So here we have my object, which is the name of the collection, which is the name of the object. And I have this string key one. If I take my object and I say my object and I put the syntax to access a value and I plop in key one, it will quickly look up and identify that value one is the only value that is associated with this key. So it's a unique key to value relationship. It makes the lookup incredibly fast, and it also provides us information about the relationship between whatever the key is and whatever the value is, whatever kind of data you want to store. Here's the syntax for accessing values. You do the object name, my object, and then you do these brackets, and then you pass the string in there. So we have these brackets, and we pass in key one, and in this case, we're going to console log out value one. Why are objects useful? Objects are really useful if you are trying to specify like attributes, specify different pieces of data that different pieces of data that have a specific purpose or have a specific function. So like in the case of a cat, right? A cat has like a name, an age, and maybe a color or a coat, right? What we're showing here on line 2 is an array. An array is an ordered list of values. They can be any value, but it's an ordered list. And arrays are optimized or they're purposed to get their significance or get their relationships in terms of their order in this list. So looking at this, I don't really know that 7 is this cat's age. What I know is that 7 is the second thing in this list. So if I had like a list of presidents, right? Maybe the order of like a certain president, that would matter. In this case, it's confusing. An array doesn't really carry information about what we're storing, but objects do. Objects, string keys allow objects to store more information about the values in it. They describe what the values should be. So to write this out, we have a name, right? We have a key called name. So now as a developer, I can say, oh, okay, Pushin's name is Pushin. Pushin's age is 7. Pushin's color is gray and tabby. So as a developer, I can come in here and say, okay, I need Pushin's age. Okay, Pushin, and then the key, the thing that I'm going to be storing or associating with the value for age, I can just write age, and that makes sense. That's an easy, straightforward way of setting up the data, setting up the object. Creating an object, we use the curly braces. An object's keys are always strings, so we don't have to write those quotation marks each time. When we're writing an object, we can just write the word as it is. So we're going to do the same thing here. On line 6, we're declaring this variable, Pushin, and what it's equal to is an object. And that object inside of it has some attributes. It has name, Pushin, age, 7, color, colon, gray and tabby. And note that you have to write these commas in between each of the keys, each of the properties of the object. But so now we've defined this object and we can use it throughout our code. Any questions on objects? Accessing a value, we talked about this a second ago, but you can use two types of notation. The most straightforward is bracket notation. You just pass a string into brackets, and that string corresponds to objects. This is really handy too because we can store strings in variables. So we can also pass in variables into these brackets. And if the variable's value, if its string value is a value that is inside of the object, it will look it up as well. That's pretty cool. So we have this Pusheen, and like we saw before, we're going to console log out the object name, Pusheen, brackets, and then you pass in the key. We can do the same thing with age, do the same thing with color. We look up name, we find Pusheen, we pull that, we log it out. We look up age, we find the corresponding value, we pull it down, console log it out. The same thing with color. If you try to look up a key that doesn't exist inside of the object, like in this case, Pusheen, and we pass in not a key in the object, what you'll get is undefined. It's basically saying, hey, there's no definition for this key. There's no entry for this key in the object. So we have name, age, color, not a key in the object, undefined. Creating and calling a method. So methods really are just functions inside of objects, right? You can store any kind of value within an object, and we can store functions. And when you store a function in an object, it's commonly referred to as a method inside the object. So right here we have Grace Hopper objects, first name, Grace, last name, Hopper, rank is a string, rear admiral, right? That's the value. And then we have my method, and my method is a function, and it console logs out, I'm from a method. So if we tried to access Grace Hopper brackets my method, it would return the function, and then we could call the function there. We can invoke it. So here we have Grace Hopper, my method, that pulls in the function, and then we gotta add those parentheses in order to call the function. And it'll log out, I'm from a method. So this is a way to create and call a method inside of a function. So there you go. We got functions, we've got objects, and we've got methods. Any questions about any of this? Anything that you all want me to demo? Maybe I'll just do a quick demo of return and functions. So let's go ahead and start coding here. Where's my JavaScript? There we go. So just to reiterate, var myfunc is equal to function, right? I'm going to define a parameter called num, and then I'm going to say just return num plus 1. Then down here, I'm going to call the function, myfunc, right? And I'm going to pass in an argument for it. I'm going to pass in 2. Then I'm going to set up another variable to hold this, my result. And then I'll console log out whatever my result is. So what happens here is we pass in the 2 here. So this num basically becomes 2. So 2 plus 1 is equal to 3, right? And it returns 3. It's almost like we erase this and write 3 here, right? When this function finishes, it outputs, it yields a 3. The last thing to note is that if I don't return anything from a function, if I don't have a return keyword, if I don't explicitly return something, the return value will be undefined. So in this case, I pass in 2. I'll just console log out the function ran. So it's going to log this out, but it doesn't return anything. So my result will end up being undefined here. The function ran, undefined. Any questions on that? Okay, cool.